Good morning. So we are going to work on our right triangle apply problems, everybody. So remember, we want to start with drawing our directions. So remember, we have north, east, south, and west. Okay, so Alex is 9 feet south of Sam. Okay, so Alex is going to be here. Sam's going to be here. He's going to throw to Gita. And Alex is 12 feet west of Gita. So we're going to be solving for C for our, so we're going to use Pythagorean theorem. So everybody, so if we're solving for a side, we're going to use Pythagorean theorem, everybody, if we have two sides. So we add those together and take the square roots, add them together. So remember, we're going to use Pythagorean theorem if we have two sides, and we're going to solve for two sides. Take the square root of each side, and we're going to get that it's equal to 15 feet. So Sam's going to have to throw the ball 15 feet to Gita. Okay, so this one. So we have an envelope. So an envelope is in the shape of a rectangle. Okay, and then we're going to go across. So it's this diagonally across. I can draw a diagonal. So that's going to be our C, and it's 16 by 12. Okay, so again, we're solving for the we are solving for the hypotenuse. We are solving for C. So we're going to have 12 squared plus 16 squared is equal to C squared. Okay, and so we can do, everybody, where we do this all together. So do parentheses. Okay, so 12 squared plus 16 squared in the parentheses, and then take the square root, everybody. That's one way to take it all together. Okay, and when we do that, we actually get square root of 400, which is 20, so it's 20 inches. Okay, on this one. Okay, Charlie bicycles 5 miles west to get home from his house. After school, he bicycles 2 miles north to his friend Henry's house. How far is Charlie's house from Henry's house? Okay, so we can draw directions again. Everybody, if it helps, just to make sure we're getting our directions right. So north, east, south, and west. So a lot of room to write that. Okay, so Charlie bicycles 5 miles west. Okay, so this is his home, Charlie's home. He goes 5 miles to get to school. And then after school, he bicycles 2 miles north. Everybody's always going north to his friend Henry's house. How far is Charlie's house from Henry's house? So again, everybody, we're still solving for the hypotenuse. Okay, so we're going to do 2 miles squared plus 5 miles squared is equal to C squared. Okay, so remember, everybody, we can put this all in the calculator into the square root sign. We get C is equal to square root of 29. Okay, and then so then we would have 5.4 miles. So remember, everybody, we're going to round to the 10th place. So his from Henry to Charlie's home. Okay, so this is Charlie's home. Is approximately 5 4/10 miles. Okay, Miss Newman is teaching geometry class. She's standing 10 meters in front of Beth. Okay, so she's standing 10 meters in front of Beth. Okay, so Newman's up here. Beth is here in front of Beth. Carter is sitting 5 feet to Beth's 5 meters to Beth's right. How far apart are, and it should say Mrs. Newman and Mrs. and Carter. Okay, so again, everybody, we're going to solve for C. So 10 squared plus 5 squared is equal to C squared. We're going to take the square root to get to the root of the problem. Remember, do the parentheses around it, everybody. And so then we get that the distance is approximately 11.2 miles or meters. How do I put miles? That would be a really big classroom. Okay, so 2 cars leave the same parking lot with one heading north, okay, and the other heading east, okay. So again, we're doing our directions again. Okay, one is heading north and the other is heading east. Okay, so east, okay, going east. After several minutes, the eastbound car has traveled 5 miles. Okay, so this is the one going east. This is the parking lot, the same parking lot, so that's PL. Okay, the other one is heading north. And they want to know if the cars are now at a straight line distance of 12 miles apart, so the north to east are 12 miles apart, how far did the northbound car travel? Okay, so we're solving for one of the sides. Remember, we need to identify C. Okay, and then we have B and A. So we're going to be solving for A. So we're going to have x squared plus 5 squared is equal to 12 squared. So remember, we can subtract 5 squared from each side. So I get 12 squared minus 5 squared. I'm going to take the square root. Of course, we're going to do our parentheses. And we get approximately 10 and 9/10 miles. Okay, so next one is a gopher. Oh, perfect for February, everyone. So by the way, said the gopher saw his shadow, so we're supposed to have we'll have 6 more weeks of winter. Okay, so on this, okay, it says the gopher dug holes in opposite corners of the rectangular yard. One length of the yard is 10 meters, and the distance, okay, so length is 10 meters, and the distance between the gopher's holes, so opposite corners, so we have a hole over here, hole over here. Okay, gopher holes, by the way, everybody, are not good for gardens. So 17 meters, and we want to know how wide, so we want to know the width of the yard, okay? So 17 is C, the length is going to be the base, and the width is A. So we're going to do width squared, or you can do X, everybody, plus 10 squared is equal to 17 squared. Okay, I'm going to subtract 10 squared from each side. And of course, everybody, you can square them first and then subtract them. So we get width squared is equal to 17 squared minus 10 squared. I'm going to take the square root. Remember to do the parentheses. So we get that the width is approximately 13 7/10. Okay, Brownie is attending a concert at the school orchestra concert. She sees her math teacher seated 9.6 meters ahead of her, and her science teacher is 9.6. Science teacher is 4.5 meters to the right of her. Okay. How far apart are the two teachers? Okay. There's the math teacher. Here's the science teacher. Here's Rona. And we want to know how far apart are the two teachers. Okay. So we're going to have so 9.6 squared plus 4.4 squared is equal to x squared. Okay, we're going to take the square root. And we get, so about 10.6 meters. So the teachers are about 10.6 meters, the math and science teacher. Okay, Paula is on a hot air balloon that's just taken off. So a hot air balloon is, so she's in the balloon. So Paula's up here, is floating above its launch point. So this is where it just, this is the launch point, everybody, where it started from. Evan's stand on the ground 16 meters. So Evan's here. If Paula and Evan are 20 meters apart, how high, everybody, so we're solving for the height, is Paula, okay? So this is C, okay? This is the base. So we're solving for H. So we're gonna have H squared plus 16 squared is equal to 20 squared, okay? So we're gonna do subtract 16 squared from each side. We're gonna have H squared is equal to, okay, that would be 0. So we're gonna have 20 squared minus 16 squared. And of course, we're gonna take the square root. Okay, so we get, so the height is 12 meters. So Paul's not too far off the ground at 12 meters. Okay, so now we have a hummingbird's nest. Okay, so we have a little nest up in the tree that is 15 feet up in the tree. I don't know if I can get in colors. I don't really have brown. Okay, so we have tree. Hell no, I'm gonna do a tree. Okay, and we have the little nest for the hummingbirds right here. Okay, and it's 15 meters off the ground, so the height is 15. And a flower is on the ground. So now we got a little flower. Okay, that is 5.3 meters away from the base of the tree. How far will the hummingbird need to fly to get from the nest to the tree? So the hummingbird's going to fly down. Okay, and we'll assume that the flower is actually really close to the ground. So we need to find this. We need to find C. Okay, so we're going to do 15 meters squared plus 5.3 meters squared is equal to C squared. Okay, and then of course, everybody, we're going to take the square root. Remember to do the parentheses. So we get the distance the hummingbird has to fly is approximately 15.9 feet. Okay, yeah, it's feet. It should say feet. Okay, so this one, Gary's building a slide for his kids. Okay, so we're building a slide. Going down. Okay, yeah, that's kind of a crazy slide, everybody, but that's okay. So picture a slide on the playground. If the ladder is 3 meters tall and the slide is 6.5 meters long, how far away is the ladder? So want this. How far away is the ladder from the bottom of the slide? Okay, so that's the height. Okay, so we're solving for x, right? So we're going to have 3 meters squared plus x squared is equal to 6.5 meters squared. Subtract that 3 squared from each side. Of course, everybody, you can always simplify it first and then subtract it. So we get x squared is equal to 6.5 meters minus 3 meters squared. And of course, everybody, we're going to take the square root. We got to get to the root of the problem. So we get it's going to be approximately 5.8 meters. Okay. Okay, everybody, you got this.